All right, let's look at how we are going to make a control limits chart using samples that we pull off the line. Okay, so the whole form of this chart is going to be the mean of all of our sample sets plus or minus some number, which is going to give us an upper control limit and a lower control limit. And so the way that we're going to do this using full samples that we have is we will take the mean of all of our sample sets that we pick, and then we're going to add or subtract from that z. And remember, so z is really talking about that z number from our standard normal charts. So a z of 3 would be 3 standard deviations from the mean on either side. And so that would give us a control limit or a confidence interval of 99.73. If we only go 2 from each side, it would be 95.45, and then I believe 1 is somewhere around 67. But it's going to be that z times the process standard deviation divided by the square root of the sample size. This is where, and I'll explain it a little bit as we're going through here, that entire idea of sample size is where things get tricky. Because, so we're looking at this example, the weights of the boxes of oat flakes within a large production lot are sampled each hour, and the manager wants to set control limits that include 99.73% of the sample means. So if we go over here to the model, and this is where I say it gets tricky. So every hour, they pull 9 boxes, and they average those together to get our sample mean. They do that 12 times, so over the next 12 hours. So basically we have a sample set where we're taking a sample at different intervals, and then we have the sample itself, which is every hour we pull 9 boxes. And people, students will get confused on this because in this case they look at it and go, oh, well that sample size is 12 because I'm doing it 12 times. That's not the case. The sample size is 9 because each time that you sample your production, you're pulling 9 units. And so in this case, if we look at it, yes, we're sampling 12 times, but the sample size is going to be 9. And so back to the upper and lower control limit, so it's going to be mean plus or minus z times the process standard deviation divided by the square root of the sample size. So the process standard deviation is something that you have been tracking for a long time. You've been looking at it. You're actually figuring out what your standard deviation of this entire population that you're dealing with. What happens if we don't know what the process standard deviation is? We have other ways to put together those control charts, but we're just going to right now focus on we can sample our line. We know what the process standard deviation is, so we're just going to figure out what that mean is, what that upper and lower control limit is, and then how would we end up plotting that in Excel. Okay, so right off the bat, what I have here is, this is for hour 1, we pull 9 boxes, we weigh each of those 9 boxes. So, box with 17 ounces, 13, 16, 18, 17, 16, 15, 17, 16. So those are the weights of those 9 samples that we pull. And so like right up here I've got sample size 9. So how do I figure out what the average of my sample is? Well, that one's easy. We're just going to come here, we're just going to average that up. So we'll go average, we will grab our 9 samples. And so for the first hour, the average weight in the boxes is 16.1, and that's repeating. It goes on forever. We do that each hour. 1, 2, 3, 4, all the way to 12. So I've already filled in the data here, so we're not going to have to average each one, but you would do this for hour 2. When they did hour 2, they got 16.8 ounces. When they did hour 3, they got 15.5, and so on. So what we're going to do is we'll just move this one down here because this is the amount that we came up with, and we'll make it look like the other ones. Let's just drop that down to 1 decimal point so everything's nice and pretty. All right, so now what do? Well, when we're dealing with these control limits, especially this is our X-bar chart, our control of the means, we are taking the average of the samples. So We sampled at hour 1. We averaged up all of those 9. That's our sample size. So our first sample is 16.1 ounces. We did the same thing at hours 2, 3, and 4. So now what we're going to do is we're just going to take the average of all these sample sets that we've got. And we'll just go here. We'll average all of those up. And then that's going to give us a mean of 16 ounces. So this is kind of the average of the averages. Okay, and so now we can sit there and we can build our upper and lower control limits based on that. Let's make this a little bit easier for when you're looking back. Let's go and let's make some range names. And so we'll just come in here and we're going to go to formulas. We'll create from selection, left column, say OK. And we'll even, let's be really technically correct, range names, control B to make that bold. I'll have to highlight that because I didn't do it first. So control B, make that bold. We'll go in here, use in formula, paste names, paste list, and there we go. So there's all of our range names. Okay, so now let's build our upper control limit. So our upper control limit is just going to be that mean. And since this is plus or minus, the upper one's going to be plus. We're going to say plus, and then this is where we're going to go to our z value, which is 3. And remember that z value is talking about how many standard deviations we are from the mean. So a z value of 3 means that we're going 3 each side. So we've got 6, and once again, this is 6 sigma because it's 6 standard deviations across the mean. We're going to encompass 99.73% of all possibilities. And then we're going to multiply that by our process standard deviation. And then I want to divide that by the square root of my sample size. Okay, and so I'll hit enter. And so our upper control limit in this case is going to be 17 ounces. The nice thing about this is the only difference between the upper control limit and the lower control limit equation is the lower control limit is the minus. These are all locked in with range names, so if I just drag this down, none of this is going to index. All I have to do is come in here, and I'm going to make that plus or minus. Okay, so now I have my upper control limit, and I have my lower control limit there. So my mean is 16 ounces, the upper control limit 17, lower control limit 15. Okay, and so now we're going to make a chart. Now, the X-bar chart, what do we have on the X-bar chart? We're going to have the average weight on the y-axis, and then we'll have the sample number along the bottom. Now, once again, sample number, hour 1, that would be our first sample, and that's made up of a sample size of 9. So we're going to run our sample numbers from 1 to 12 and take a look to see, is our process in control based on means? Now, the easiest way that we're going to do this is we're just going to plot these two against each other, and then we're going to draw a line for our mean and our upper and lower control limit. And so really the easiest way to do this is I'm just going to come up here and I'm going to go equal mean equal upper control limit equal lower control limit. And this is just to give me some points so I can make a line. So I'm just going to go, we're just going to drag that down. They'll all stay the same because it's not indexing. And so we're going to stop right there. In the next video, we're just going to build the chart.